All right, folks, it's Bass Action back in action here. On this page of notes, we're going to look at standard form of an ellipse and of a hyperbola. Later in the chapter, we'll look at writing the equations and graphing them. But for right now, let's first determine how did I know that this was going to be an ellipse. I scanned the equation from left to right, looking for how many squared terms I had, and I found a 49x squared and a 16y squared. What I noticed is that both the 49x squared and the 16y squared, those both have the same sign. And because they both have the same sign, but their coefficients are different, that's what's going to make it an ellipse. I know then that on our final equation, the whole thing's going to equal a 1 because those coefficients are different. And then I've preset up the equation to complete the square. Remember, what we're doing is we're grouping the x and the y's. So I've grouped the x's and I've grouped the y's, and I've factored out the leading coefficients. Only the leading coefficients, not the GCFs. Because my constant was already on the other side, I didn't have to do anything for that. So just following our process for completing the square, taking the b value and dividing it by 2. So b divided by 2, squaring it, gives me a nice 4 in here. Anything in the parentheses needs to be multiplied by its coefficient, which means when I balance this equation, it's a 196 that goes on the other side. In the next set of parentheses, I take my b divided by 2 and square it. That gives me a 25 in the blank. Again, anything in the parentheses has to be multiplied by its coefficient, so when I balance the equation, I get a 400. Now, the next step, what we're going to do is we're going to have this 49. We can write our perfect square trinomial, so x minus 2 squared plus my 16 and my y plus my 5 squared. Collecting all my terms on the right-hand side gives me a 784. Now, we said in the beginning this needs to equal 1, so what we're going to do is we're going to divide every term by that 784. Everything gets divided by 784, and then we will reduce. You'll reduce these, and you'll reduce these. So our final equation looks like x minus 2, quantities squared, over a 16, y plus 5, quantities squared, over 49, equals 1. Real quick note here, you'll notice that on this problem, the 16 and the 49 flipped places. Do not assume that that's a pattern. That just happens to be the way this problem was written. That does not always happen. The other thing with our ellipses is we will write the x squared term first, so do get in the habit of writing it that way. So there's our final answer for our ellipse. Next one is the hyperbola. When you have a hyperbola, you do want to slow down, be a little bit more careful on these. So how did I know this was going to be a hyperbola? Scanning the equation, looking for the squared terms, I find a 2y squared and a negative 3x squared. As soon as you see that you have the two squared terms, but they have different signs, as soon as you see that they're different signs, you know it's going to be a hyperbola. Nothing else matters. Next thing that we want to remember is that the equation does need to equal 1 when we're all finished. I've preset this up for completing the square. I factored out my 2 from my y squared terms, and on the x squares, or the x terms, I factored out a negative 3. Be careful on that negative because it's going to impact our signs. And in fact, I just caught myself when I wrote this here. This should have been a minus right here. Make sure that this one's a minus because it was a minus in the original equation and we needed to divide by negative 3. I did move my constant to the other side, so you can see that now became a negative, and I put in all my blanks. So there's a lot of little details, especially in the hyperbolas, that you need to be careful with. Easy to make some mistakes. So let's start completing the square. 16 over 2 squared gives us a 64 inside the parenthesis. 64 times the 2 to balance the equation is going to give us a 128. Negative 2 divided by 2 squared is going to give us a 1 in the blank. Balance the equation, Careful, it's multiplied by a negative this time, so this is going to be a -3. So now I have a 2, I have a y plus 8 quantity squared, minus a 3, and x minus 1 quantity squared, and a 36. This entire equation needs to equal 1, so we're going to divide by whatever we get on that right-hand side, and then simplify. So y plus 8 quantity squared, the 2 over 36 reduces to an 18, minus x minus 1 quantity squared, the 3 over 36 reduces to a 12, and we get a 1. When we write the equations for the hyperbolas, the negative term will always go second, so the leading term should be positive. Okay, that's all that I've got for ellipses and hyperbolas. When you come into class, we're going to do more practice with this.